Hey, Nico, are you ready to start the session?
Yes, let's get started.
Okay, so I launch officially the Q&A session.
Great.
Let's go.
So thank you everyone to join this first Q&A live. This is the really first time we are doing this, so it will be a kind of experiment with all of you. The idea of this live session is to reply to any kind of questions regarding Luos that you guys could have. And just to present myself, my name is Nicolas. I'm CEO at Luos. So basically, Luos was my student project 15 years ago, and today it's a company with an open source technology. And at Luos, we are aiming to provide technology allowing developers to develop some agile devices in the embedded world. And to do that, we provide a microservice embedded systems orchestrator called Luos Engine. So this is the introductions. I don't know if you guys have some questions directly to ask me. So the idea is just you ask me some questions and I try to reply to it as I can. Hello, Alan.
Hello, Nico. Can you hear me?
Yeah, perfectly.
Oh, thank you.
So, who have any kind of questions? So you can ask me directly by talking, or if you want to. Also, I think there is some chat directly in the general channel. I don't know how to display it, but there is. Yeah, here.
Mm-hmm.
So as you prefer, you can just ask directly using the text, or directly asking by talking.
Yes, Nicolas, I got one question. I know well the project, but maybe, in your opinion, what is the difference between Luos and the difference or the complementarity maybe between Luos and an embedded operating system?
Yeah, basically, Luos is not an operating system. This is a technology allowing the developers to encapsulate any kind of embedded system features into something we call a service. And this service is a kind of box with an API on top of it. And then Luos will allow you to exchange information between the different services available on your entire system using any kind of network. So basically, this is not an operating system. This is a way to separate your developments in small services. And Luos can run on top of any kind of real-time operating system. Basically, you just have to create your own tasks and to run the code of all your services as you want. And also, you can have multiple tasks running for only one service as you want. So basically, the way you will code your program will be exactly the same. The idea is just to declare to Luos your different features. For example, I don't know, a motor, a battery, an algorithm to filter some sensors value or something like that. You just have to declare those features into Luos, and Luos will take care of it. So basically, this is really different things. And if you need to have a real-time operating system, you can. If you don't need to have any kind of LTOS. You can run Luos directly in bare metal if you want to.
Yeah, pretty clear.
Any other one?
Yes. Do you hear me?
Yeah.
Okay. So I have a general question about Luos. I think, well, is it hard to learn Luos? Is it hard to begin with Luos? Does it take time? On one side, if you know about embedded system, and or on the other side, if you don't know but you are interested in learning, what kind of basis do you need?
Okay. Basically, Luos is not so complicated. The code side is really easy. You just have to masterize some something like 2 or 3 different functions. The difficultest things to get started with Luos is the concepts of microservices and how to deal with it on the embedded world, because microservices is more focused on the web world, on the normal software world, and embedded don't really use this kind of methodologies. And Luos just combine those two words, allowing embedded system developers to think their product development as a microservice system. So this is the biggest thing which is difficult to understand. This is how to use microservice in the embedded world and how to make it efficient, because the first mistake when you start with Luos is to create tons of services for everything, and then your system will have difficulties to scale. So you will have to find the good tuning on how many services you will have on your device and how to regroup those different things. And that's also why this Discord community is really important. This allows developers to just ask about it and to talk about the different projects you guys have on this community, and challenge the ideas on how to organize your code, and to how to regroup the different features together to have something real-time, efficient in terms of memory and CPU consumption and something like that. So basically, learn Luos is not really difficult on the embedded side. To begin, we have some tutorials directly available on our website. So let me show you. I can just share my screen. On the resources here, we have some tutorials. And to begin, you can just go to the Get Started tutorials. And here you can have different parts of this Get Started, allowing you to just test extremely fast and easily what Luos is capable of. Then you will be able to move to your first things category, such as those 3 categories here. On these parts, you will learn directly how to create a service, how to directly code your embedded system using Luos. And you will see that this is kind of easy. And if you just follow those 3 different tutorials, you will be really advanced on the Luos masterization. And if you are not an embedded system developer, it will be easy for you to just understand what is the microservice and how this should work. And the thing that you will have to get is how to make a normal system interact with Luos. Because for those that don't know that, basically because Luos encapsulates any features into a services, and any services provide like an API. In the Luos point of view, there is absolutely no differences between exchanging information between one service in the same between 2 services on the same board, on multiple electronic boards, or between one service on a board on a computer, a cloud application, or something like that, because we are using this API. So basically, you can interact from program on your computer directly with a program embedded directly into electronic boards, such as, I don't know, a sensor, a battery, or a motor, or anything like that. And this allows normal software developers to easily interact with embedded world. And we have a lot of users that dealing with it like that. We have a lot of robot developers that just developed some drivers allowing them to use motors or sensors and things like that. And at the other side, they are using a computer with ROS on it, and they are controlling all the sensors and the motors directly using high-level programming through ROS. So basically, it's kind of easy. We already provide some framework work, or allowing you to deal with Luos using Python, ROS, and things like that.
Okay, thanks. What write a question in the text? Maybe you can read it and answer to.
Aren't you concerned about the fact that orchestrators in embedded systems are highly dependent on the product they are used in? Luos seems like the kind of stuff the maker should have entire control over. Using Luos and ending up forking it after a couple of months seems cumbersome. How do you respond to skeptic like me? Yeah, of course. The big thing about Luos, and we are struggling a little bit with that, is that big industrial companies fear about this kind of technology because, as you mentioned, to be efficient, Luos has to be used at the beginning of the project and change a lot of things on the way the guys develop the product. Because basically, when you develop Luos, you will be able to have small strike teams working on only one pieces of the device. For example, I don't know, the motion sensor of one device, and some other team will work on the motor part of the device. And those two teams don't have to talk together. The idea of Luos is to allow them to just develop their services, and then when they plug it together, it will work. So this is the main idea. So this is a big change for big companies. And right now we start to have some guys coming from critical industries. We already have some advanced use case, such as Nimblebot, which is a company developing robots arm for nuclear plants. And they are working using these robots directly in the reactor of the nuclear plants. So this is like a highly critical usage of Luos. And this is kind of working right now. And we have a lot of contacts with other industries, such as aeronautics, automotive markets, medical markets. So this is the beginning for us. And to comfort the skeptics, guys like you, Wad, we are working a lot on testing this technology and to providing results of those tests publicly, allowing anyone to just see how we are testing it and how we are using this kind of test. And I can just show you, but we have some work in progress things right now, and this is like a test platform. And when we push something on the GitHub, this platform just downloads the branch and run a lot of different tests on complex configurations using a lot of different boards, and changing a lot of network configuration dynamically to make as many tests as possible. But testing this kind of technology is extremely challenging because we are working on modularity, and modularity means infinite possibilities in terms of number of boards, configurations, and things like that. So it's kind of really difficult for us to just check any possible usage of this technology.
Hi, Nico. This is Alan. Thank you for your presentation, for your explanation about Luos. And I have a question about the industrial application. Do you have some CAN bus driver or something more industrial, or the idea is that kind of driver should be in the RTOS, like NuttX, FreeRTOS, Zephyr, and others, and Luos will just provide some wrapper or something like that to use that driver? Okay.
Yeah, basically our work is not to develop drivers, and I think this is not what we are doing, and this is not our job, and we are not really good at it. We have some examples on the Luos repository, allowing just engineers to just understand how to develop their own. But in any case, when you are developing a specific product, most of the time you will have to develop your own electronic boards with specific chip and the specific usage of the GPIO and things like that. So you will have to, most of the time, redevelop your driver when you have to interact with a piece of hardware. Luos is here to orchestrate the different drivers and application you have on your device. And Luos also allow you to make a clean and good separation between drivers and applications on your complete system. So basically you can have like a motor drivers on the board. This driver can just run on a really small board without any real-time operating system in any kind. You have another board running some complex algorithm using those kind of motors, running on FreeRTOS such as NuttX or FreeRTOS or something like that. And this application can have a direct access to the motor driver running somewhere else. And this is extremely powerful because you have a really good separation between applications and drivers, and your application don't rely on any hardware. So basically, you can just copy paste the piece of code running your application, and you can move it on any microcontroller. It will work the exact same way. And in the future, we are planning to work on the native supports. As Alan, I see you. I know that you already have a look at it. And the idea of this native supports is to allow Luos application to run directly into a computer. This way, we could be able to have like drivers running on the actual electronics and have behaviors on complex algorithm running directly on the computer during the development, allowing you to extremely easily debug things and to have as many memory you want on everything you want. And then when the thing is working, you just have to copy paste your code directly into your embedded target, and this will work the exact same way. And the only difference is the path to the information on where which is the network Luos will use to transmit this information, but the information will still the exact same way, the exact same information.
Okay, thank you very much, Nico, for your complete explanation about the body.
You're welcome.
Yeah, and by the way, we'll have the NuttX online workshop next month, by the end of next month.
Okay.
So you guys all are invited to participate. I will post the link here to the website. If you have some ideas to submit, the deadline is in 3 days.
Okay.
Maybe we can work together to present some minimal proof of concept of getting Luos work on NuttX to the event. Because
I already know that you have some ideas about how to the complementarity between NuttX and Luos. Can you give us some more details about your ideas about how to make those two things work together?
Mm-hmm. Basically, my main idea was to base it on your native initial port and get it running on the NuttX. You can imagine NuttX like a small Linux. I think nobody here yet try it, but you can run NuttX on many boards, like any ESP32 boards or the Raspberry Pi Pico board and any others. There are more than 200 supported boards in mainline. Some very small, like this one I suggested, but there are also some big board with powerful processors, like the BeagleBone board and IMX6, for example. And the idea is to run these Luos like an application just to serve some basic information from the board. For example, to send temperature or accelerometer or other sensor device. I don't know if it is feasible or not yet, but I suppose it will be possible to do that.
Sounds good. So let me just try to re-explain what I understand to what you just said. So basically, Luos is using something we call HAL, hardware abstraction layer. And the idea of this is to indicate to Luos how to use the hardware Luos is running on. And Luos will be able to use this interface to access to the network, to the memory, to different things, to the timers, for example. Luos needs to work properly. And I think something that Alan mentioned previously on the Discord was we could use NuttX as an HAL for Luos, and this way we could access directly to the physical resources available on the board using POSIX interfaces, and this could allow Luos to access to all the boards Alan just talked about. Are you agree, Alan, about this?
Yes, you got it very clever and very clear. Yes, that is the idea, because as you explained, Luos doesn't implement all the drivers. So the idea is to have it supported, maybe following some standards, like the POSIX that is supported by Linux, NuttX, Zephyr, VxWorks, macOS, all the Unix BSDs and so on. Then it will open doors for many other applications. I think the POSIX is like a way to go, because normally for embedded system in the past, many people didn't realize that possible to use POSIX. But then many years ago, the VxWorks start to using POSIX, and then when NuttX was created, it also started to use POSIX, and now we have others RTOS supporting POSIX, like even FreeRTOS is not complete like NuttX, but it has basic support to POSIX. Also, Zephyr has good support, not so good like NuttX, of course, but is good. There is also RT-Thread from company, Chinese company, that also...
Never heard about this one.
Yeah, it's also supporting POSIX.
Okay.
And yeah, I suppose if you can support many RTOSs and many high-level OSs, you have a POSIX layer to drivers or other features, you reduce your time to market. So you don't need to to reinvent the wheel all the time.
Yeah, for sure. I'm sure this is something really interesting you mentioned, is that embedded system developers don't really cared previously about the POSIX API. I think right now the mind of embedded system engineers is moving to use this kind of standards because everyone is using it, and it's allow embedded system developers to create developments that will be reusable extremely more easily. So I completely agree with you. And just to give you a little bit more of context about Luos, is historically Luos was synced to work for bare metal applications. That's why we don't have a lot of usage on use case on examples using real-time operating system. And this is something kind of new for us. And we just make like an experiment using FreeRTOS a few months ago. And that was like kind of really easy for us to just create something working with FreeRTOS, because Luos was already ready to multi-threading and things like that. So this is something new to us, and we plan to develop a lot of support for different kind of real-time operating system in the future. So NuttX is on top of the list right now, thanks to you, Alan, and we will work on this kind of subject during the coming months.
Very nice, Nick. Thank you.
You're welcome.
So, Nico, yes. I have a question about when you answered Alan's question, you were talking about drivers. And what I understood is that those drivers I can develop will be modular. My question is, if I want to share the drivers, if I want to see if other people make drivers that I can use, do you plan to have something to make to download them or to make them available to the community?
Yeah. So basically, I previously mentioned the differences between a driver service and an application service. But basically, the idea is to application service don't rely on any hardware, so you can move it anywhere. And basically, you can just copy paste this folder on a project of someone else, and this will work the exact same way. This application, we will look at some resources available on the device and just use it if they are available. So I don't know if you already see the bike alarm demonstration. We have a YouTube video about it, but this demonstration video use an application. So basically, if you copy paste the alarm application, this application will find a way to create like an alarm on your device. So, and the same way with drivers, but drivers is a little bit more complicated because when you develop your drivers, of course, you will have some hardware specificities, and your drivers will only work on one specific electronic board or one specific configuration of a given board. So it's not so easy to share a driver, and it's more easy to share an application than the drivers. But still, you can share a driver on application, and we call it a Luos package. A Luos package is a folder with some code on it, and this code will have one or multiple services, and you will be able to copy paste this folder from one project to another one. And this is where we are today. Right now, you need to copy paste it from one project to another. And in the beginning of the next year, we plan to work on something called registry. And the idea is to just give Luos some dependencies, such as you can do with Platform.io. But you can say, for example, I want to use this driver service on this application service, and the registry will be able to download those services and directly modify your code to integrate it directly into your project. Basically, this will rely on Platform.io, and we are working with Platform.io on this subject right now. So this is a work in progress topics. And at the end, we plan to develop like a website, again, based on Platform.io registry, allowing to display all the Luos packages available and created by the entire community, allowing anyone to just reuse the work of others extremely easily and to make it work on any boards anywhere on the device.
Very cool. Thank you.
Great. Time flies. I saw Jerry Khan write a question in the chat. Maybe you can read it and answer.
Yes, Jerry Khan. But are microservices optimized for embedded? I mean, what is the overload of Luos in terms of memory and CPU? This is a really complex question because it depends a lot of how many data you will pass through Luos. So basically, Luos have been developed to work on extremely small configurations. It can work on small 8-bit microcontrollers with something like 30K of flash and 2K of RAM memory. And basically, Luos allow you to masterize all the memory consumptions you will have, and we have a lot of different buffering, and you can size for example, the message allocation buffer. You can directly size it, and Luos don't do any kind of dynamic allocation and things like that. So, in kind of memory, you will have a perfect control of how many RAM Luos will be able to use. And we also have some statistics allowing you to analyze if Luos is comfortable or not. And you will have like some ideas about how to optimize it in terms of memory consumption. And regarding the CPU consumptions, basically it's scaling depending on the number of information you want to transmit between the different microcontrollers you have on your device, because Luos is mostly running codes when there is some information that are transmit. And if you don't transmit any kind of information, Luos don't do anything. So it depends a lot. And so, yeah, and a lot of things are started directly from the interrupt. So when you receive a message, there will be an interrupt, and Luos will just create some job, and then those jobs will be executed in the Luos loop you are running on your main. And if you don't have any interruption, you don't have any Luos tasks, and Luos don't do anything. So this is the main idea, and the idea is to have a program that uses the minimum CPU time as possible, and it's depend on how many messages you are transmitting.
Okay, great. To conclude, can you talk about maybe the next release, and maybe if there are some call for contribution?
Yeah, sure. This is a really good idea because I think Aquaman is currently working on the release of the new revision, which is 2.5.3, which will be released in few hours. In this new release, I think I have the changelog just right here, so I can just display to you this. Okay, so this is the changelog we will have. So nothing game-changing here because this is like a bug fix release. We just improved some workflow on GitHub, allowing to accelerate some build thing. We have some bug fix. Some of you guys just showed us. We have some cleans things also. We have added some examples for ESP32. We'll still have some work in progress example. For example, some of the gate WebSocket examples we are working on right now, and we don't have something compiling already, but this will be integrated into the next release, which will be probably the 2.6.0 that will come, I think, in few weeks. So nothing changing here. And what was the other questions, Manu?
Never mind, because NTD want to ask 2 questions.
Yeah.
So let's go, NTD. You can speak.
Hello, nice to meet you. I want to ask about the network of nodes about Luos. As I understand it, we can have many microcontrollers as nodes, and they can have some services in it. For example, controlling different things like that. Do we have any way to dynamically update the firmware of any node? And if the updating of the firmware can fail, or if it fails, can they affect the other nodes around it? It's one of the questions.
Okay, so let me reply to this one. Do you have another question, NTD? Okay, so I will reply to this one first. So Luos engine access to a communication way, which is the network. Right now, when you have one way to communicate, which is called robust, and this robust thing use an half duplex serial interface to broadcast the information to all the nodes available on the system. So yes, you can have as many sensors on motors, on batteries, on drivers you want on the boards, and all those boards will be able to communicate in a complete multi-master way to any other one. After that, about the update capabilities of Luos, because Luos access to the network, and we also have an access to the flash. So basically, we need to add those 2 access to make Luos run. You can compile Luos as a bootloader. And basically, when you do that, Luos provide you a binary you will be able to install where you want on your microcontroller. And when at the boot, this bootloader will start, and you will be able to update the firmware using the Luos network. So basically, to do that, you will have to use a gate somewhere on your network, allowing you to link a computer with the actual network on the different nodes of your network of your device. Sorry. After that, when you have this gate, you will have access to all the bootloaders of all the nodes of your device, and you can create like a script to just flash all the board you have on the device. And these bootloader have some security, allowing you to be safe, even if your firmware, the firmware you just uploaded to it, is corrupted. So basically, if you have a crash on this firmware, Luos will be able to see that this firmware doesn't run properly, and you will fall back on the bootloader. And even if you have like a complex situation where sometimes the applications crash and you want to update it, you can force the erasing of this application and go back to bootloader. So basically, we don't have like a way to completely block this bootloader right now. We have a lot of things to improve on this side. And this is something that Victor in the Discord will work on a lot during the few weeks coming. And we will have to also another thing which is kind of challenging is that right now Luos is kind of an early technology. It's kind of a young technology, so we have a lot of things moving around every day, and it's kind of difficult for us to keep all the revision compatible together. It's still a little bit complex for us to do that. So to patch this, Victor is working on an application able to update the bootloader, allowing you to also upgrade the bootloader directly into your board. So this is something that will probably appear in few weeks too. And there is something else that is extremely important, and we plan to work on soon also, is some microcontrollers provide multiple banks, flash banks, allowing to have like virtually two banks that you can swap from one to another one. And this is really interesting because we could just flash the firmware on one bank, and if this flash fail or if this application fail, just fall back into the other flash, allowing you to have you have one working firmware and you want to upload a new version, and you may put it on the second one. And if this one fail, you fall back and run the previous revision. And this is like a security system that we could use to prevent this kind of problems. And also, I already mentioned that, but we have some users working on the nuclear industry, and we already have some questions such as what's happening if a nuclear particle just hit some parts of the flash and corrupt completely the program, and how to deal with it using the bootloader and Luos. So basically, if this kind of thing happened, your program will probably crash somewhere, and you will have like a hard fault or something like that. And on your project, you have to take care about when you get this hard fault interruption. Okay, we have like a Luos function you will have to call to say, okay, this program is dead and I don't want to use it anymore. And then Luos will go back in the bootloader mode, and you will be able to just reflash your application as you want to.
Great.
Thank you very much for the detailed answer.
Sorry?
I was just saying that we'll get another question about the business model of Luos. Yeah. How do we will earn money?
Okay.
We will earn money one day.
Yeah. This is a really good question because I already mentioned that I'm CEO. So basically, we are a company, but mainly our main goal is here to provide the tools for free for any developers, allowing them to get rid of complexity and to be able to have the flexibility and the agility that we have in software, but directly into the embedded world. Basically, the main goal of Luos is to make hardware as agile as software. And because we are a company, of course, we will have to make money one day. And we will make money because we think that this is the best way to make this technology grow in the entire world and allow anyone to use it without any kind of bug or thing like that. And this takes money and really a lot of time. And we are already a team of 9 engineers at Luos, and we need money to make those engineers work on the library. So basically about our business model. So this Luos engine technology will be free and will remain free always. So basically, guys, you can use it for free, and there will be this technology will never be payable for in any kind. So you can use it for free in any kind of project without any constraints. And basically, we start working on some additional tools that will be SaaS tools, allowing developers to be more efficient on the usage of Luos. So I already mentioned some of them. So the registry I mentioned previously will be in some way paying tools, because we already have some developers that want to develop things and sell those programs or electronic boards or, for example, motors or sensors or things like that with Luos inside directly. And we will allow them to just sell it directly into this hub, into this registry, allowing any developer to just buy it through the platform, the Luos platform directly. And this guarantee you that this motor or this sensor will be plug and play directly into your device. So this is one of the tools. We're also working on something we call Luos Inspector, which is a SaaS tools, a web tools, allowing you to inspect what's happening on your device. And the idea is to have like a timeline, and we will be able to tag and to log all the events anywhere on your device at a nanosecond scale. And this will allow you to just understand and visualize what's happening on your device. And you can make it like a trace, allowing you to have like an offline device running somewhere. And when there is a crash, we save like a file, and you can download this file and inspect it directly into this web tool. And this is something we plan to do. So basically, our business model will rely on like a SaaS model. We'll provide some tools, web tools on our website, allowing you to accelerate your product development using Luos.
Thanks, Nico. Maybe to finish, a word about call for contribution.
Yeah. So just recently, Simon opened some call for contribution. So this is something really new. Right now, we have a GitHub page with about it. So let me just find it back for you, so you will be able to see that. But mainly, you can go to Luos Engine, and you can. Okay, so let me share my screen. It will be easier for all of us. Okay, so here is the Luos Engine GitHub page. So basically, you can just go to the issues, and then you will find the label called Help Wanted. And this is all the issues we have right now, and you guys can just have a look at it and contribute to it. And we also have like the good first issue tag that means that any users, even the ones that never use Luos but just want to help this open source initiative, can start with, because this is kind of easy to fix bugs or things like that, or improvements, for example. So basically, you can go there, and also we have a documentation page about it, so you can check it out on the Discord. Perhaps, Simon, you can send back again the message on the general discussion, allowing anyone to just have the link of this contribution thing.
Yeah, great. Thanks, Nicolas. So maybe if you want to continue the discussion, there is several channels in which you can ask your question. And I think, Nicolas, you're still available to chat by...
Yeah, for sure. I'm still available to reply to any kind of questions. So if you don't have any time to ask your question here today, feel free to ask me or to ask the community about this, because I'm not the only one to masterize Luos here. We have a lot of guys, even guys that are not maintainers of Luos, that are better than me to reply about some of your questions you could have. So feel free to ask us on the help section, and we will reply to your questions as fast as possible and help you as we can.
Right, yeah, but you are the only one to be connected 24/7. So that's why
perhaps. And so thanks a lot, everyone. And let's continue by chat. And I hope you will share with us a lot of really great and cool projects using Luos. So do not hesitate to share this, because this is always really interesting for us to see what you are doing with this crazy technology. Because right now we are really focused on this technology, but it's always a victory for us to see what you guys are doing with it. So thanks a lot for this session, and have a good day, and see you soon.
Bye, everybody.
Bye.